Draw the Maxwell-Boltzmann distribution curves for a fixed mass of a gas at two different temperatures. This gas decomposes when heated. By reference to these distribution curves, explain why the rate of decomposition of this gas increases at higher temperatures. So the first thing we need to do is to draw these two distribution curves for two different temperatures. So let's start by drawing some axes. We have a number of molecules or gas particles up the side. And we've got energy along the bottom. And our first curve, we need to start at the axes at 0, 0. The peak needs to be a non-normal distribution, so skewed to the left, so it goes up faster than it comes down. So it's more like a ski slope on the way down. It's a bit like a ride at Alton Towers. And then it's going to become parallel to the x-axis at these higher energies. And we can mark on the activation energy, and we can shade an area of the curve that represents the number of particles with sufficient energy to decompose in this reaction. I'm going to call this curve temperature 1. If we want to draw a higher temperature curve where T2 is greater than T1, we need to skew this. We need to make our peak be lower and to the right of the first one, trying to aim for what equates to the same area under the curve. So our T2 curve is to the right and lower, and the area under the curve looks roughly the same. So we've got this higher area after the lower area before, and if we now look, we can see that the area with energy greater than the activation energy is much higher. Okay, so we crossed our curves only once. Why does it react? So the question is why the rate of decomposition increases at higher temperatures. At higher temperature, which in our graph was T2, many more particles, which is the shaded part of the curve, have energy greater than or equal to the activation energy. So many more successful collisions per unit time, or frequent successful collisions is another way of saying that.